Yeah, good morning, Chris.
Good morning.
How are you doing today?
Good.
All right, I thought what we would do today is kind of review a little bit of everything that we've talked about, or at least some of them. And in fact, let me say this, that you know that booklet you have that I took photos of 3 or 4 pages, and you said that that's what they told you you needed to know by the time school started? Well, there must be a lot more than just those 3 pages.
Yep, he said those are like the main ones that you want to focus on. And then after that, we just go through the 5 pages.
On the which 5 pages? The next?
Yeah.
Is that something you can send me copies of?
Well, I don't know. Like, he didn't really give us specific, like, numbers of the pages. He just told us to, like, find something else after we get those pages done.
All right. Well, I feel pretty confident that everything we're doing is applicable. In other words, you're going to have to know it at some point. We are not covering anything that you won't have to know. The question is, when will you have to know it? And that's just something we're going to, I guess we can just keep going. It's kind of the beauties of algebra. It's not like geometry. If we were talking geometry, 2/3 of what they teach you in class, you won't ever have to know again. You're not going to be tested on it on the ACT or the SAT or any of those tests. But algebra, everything we've covered, you're going to have to know at some point. Either by the end of your Algebra 1 class, possibly during Algebra 2, but definitely for the ACT and the SAT. So let's just review a few things. See how you're doing. What?
Go.
Just give me the answers.
That is 4 and 2.
What's the answer?
I mean, 6 and 2.
Remember the goal. The goal is to separate it into factors, one of which is a perfect square. Give me the perfect square number starting at 4.
It was 4. I'm sorry, I'm trying to remember.
That's 2 squared. The next one is 3 squared.
That is 6 or 9. And then, I'm sorry, I completely forgot about
Well, if this is 2 squared and this is 3 squared, the next one's going to be 4 squared.
So that's going to be 12. 3. 12. Sorry.
All right, let's back up.
16. Sorry.
That's 16. Let's back up. You can't do anything in math if you can't be good at this. That's just a matter of fact.
Yeah, sorry.
I mean, you've got to be able to be proficient at this. Good.
Positive 48. Test. Versus negative
here, what'd you say?
-3.
So how come you do so good on these, and yet when we get into algebra problems that require merely this kind of stuff, forget it?
I don't know, I'm sorry. I just forgot about the perfect squares. I kind of had a little, like...
Alright, so let's go back to what we were doing here.
Okay.
So what's 4 squared?
16.
Next one?
It's 5 squared, right?
Uh-huh.
Right. That's 25.
The next one?
That's 6, so that's going to be 36.
Alright. What factors of 12 have one of them being a perfect square? What two numbers multiply together to equal 12? Let's go through the process of factoring a number. What comes next?
There's 12 in one, and then we put, isn't it half that, and then...
Half this, double that.
Alright, so 6 and 2.
Do it again.
3 and 4? Or 3 and 3?
No.
No.
Half
Right.
this, double this.
Yeah.
Okay? So, what factors of 12 have one of these numbers over here?
4.
3 and 4.
Yeah, 3, 4.
Only 3 and 4. In other words, you're never going to use that, because that doesn't help. But you do have options here. It certainly is true that it's the square root of 6 times the square root of 2. That doesn't help you simplify it. Unless one of these numbers is a perfect square, it doesn't do us any good. If I write it, and I'm going to write always the perfect square number first. In other words, root 12 is equal to root 4 times root 3. And then root 4 is what?
It's going to be 2 root 3.
Yeah. So there's the process and the answer. This list of numbers over here, obviously it goes up. And the next one is 49, 64, 81, 100. And in general, you don't have to worry too much about these because they don't tend to give you problems. In other words, obviously if I'm talking about root 12, the only possibility are those two. In other words, there's no way you're going to have a factor of 12 that's greater than 12. You know what I'm saying?
Yeah.
So when you're working with relatively small numbers, you just have to consider the smallest perfect square numbers. Now, if you're working with this, different story. What would that be?
That'd be 100.
Okay, remember it's the square root of 100. Don't forget that.
Root 100 and then root number 2.
And then next step.
These 50.
Hold on, what?
Root number 50 and then 2.
What's the square root of 100?
Or 10, I'm sorry. Sorry, I was just cutting it in half. I forgot to actually do the root.
It's all right. A common mistake that a lot of my pre-algebra students make is frequently they mix up addition, multiplication, and squaring, or square rooting. So it's very important that you keep all of those separate. In other words, 2 plus 3 is 5, 2 times 3 is 6. I'll have a lot of students answer 6 for that, or 5 for that. Merely meaning they're mixing up the difference between multiplication and addition. And you cannot mix those two up. It will screw you up totally.
Yeah.
All right. Let's try this one. What's that equal to? There's a few ways you can do this. Yeah, we can simplify that first and then do the multiplication, which might be easier. Or the principle involved here is if we have the square root of a times the square root of b, that's always equal to the square root of a times b. So we could do that, and that actually is going to be the simplest. So what's the square root of 3 times the square root of 27? And this time you can use a calculator. Even though you don't need to. In other words, this is not covered on A+ math. You don't get problems like this. But notice the solution is all single digit stuff. 3 times 7 is 21. Carry the 2. 3 times 2 is 6. With my carried 2, it's 81. All math is single digit math. It may take a couple of steps. In other words, this is 1 digit times 2 digits, but in reality, it's 1 digit times 1 digit, and then 1 digit times another digit. So that's why it's so important to be proficient at single digit math. So I can say that this is the square root of 3 times 27, which is the square root of 81. What's the square root of 81? When you get numbers like that are perfect square numbers, now that's when you want to draw on your perfect squares numbers. What number times itself is equal to 81? What do those digits add up to?
9.
That's the answer. If the digits add up to 9, it is divisible by 9. So if this thing is divisible by 9, 9 must be the answer. It obviously isn't 9 times 8 or 9 times 10. It must be 9 times 9, especially if this is a perfect square number. So we can get to 9 that way. Let's examine how else we can get to 9. Let's convert this. What is that? Let's say I decide to simplify this root 27. What does it simplify into? What two factors? One of which is a perfect square. Okay, hold on. Let's go through the factoring of this. Now, notice that I cannot cut 27 in half.
No.
What can I do to it? Can I cut? The next thing to consider, if you can't cut something in half, try to cut it in thirds. If you can't cut it in thirds, cut it in fourths, and then fifths, and then sixths, and so forth. Can you cut it in thirds? About 9.
Yeah, it's going to be 9 because 2 and 7 make 9.
So I can cut that in thirds, which means I have to triple this. So those are factors. I still can't cut it in half again. I could still cut this in a third and triple to that. You still there, Chris?
Yeah.
Okay. But notice that those two sets of factors are the same. So in other words, I've gone as far as I can when I get to here. Okay, well, that's a perfect square number. That's got to be part of my answer. So I'm going to separate this square root of 27 into the square root of 9 times the square root of 3. Like that. Okay, now I can take this, and I've got square root of 3 times 3 times square root of 3. Okay, now I got all three of those multiplying one another. What's square root of 3 times square root of 3?
Square root of 9.
Which is what number? Now, you don't want to do it that way. I mean, I see why you did it that way. But the square root of any number times the square root of the same number is that number. You don't need to multiply 3 times 3 to get 9. You know that the square root of 3 times the square root of 3 is 3. Just like the square root of 4 times the square root of 4 is 4. Square root of 117 times the square root of 117 is 117. Okay? So, this now becomes, I haven't lost that. I still got that 3. But when I multiply this times that, I get another 3. That's equal to 9. Same answer we got the first time. Now, it may seem that this was a little harder to do, and it was definitely one step longer. In other words, if I just multiply these two numbers together directly, I get square root of 81, and I know the square root of 81 is 9. So I'm right there. But notice the way I did it, the second time, I never dealt with a number bigger than 9. Which makes the math easier. In other words, if you're doing it without it, you might need a calculator to realize that square root of 81 is 9. Or you might need a calculator to multiply 3 times 27 to get 81. But you don't need a calculator to do this step and this step and this step. Those are all single-digit stuff. All right. Let's jump around. First step.
Alright, so the first step is to get the x by itself.
Yeah, that's our goal. Just end up with x equal some number.
So we're going to add 9 to it.
Okay, so what's the next? Read the next line to me.
X squared equals 16.
What is that number? By the next line, I mean go ahead and add the 9 to the 16.
X
So now what's the next step? Remember, we're trying to get x all by itself. How do you get x all by itself if you're starting with x squared?
I know this, right?
Take the square root of both sides.
Yeah.
Remember that technique. That's a very common technique. What I mean by that is just simply this. Okay, and that leaves x by itself. And remember, just remember that every time you have to take the square root of both sides of an equation, your answer begins plus or minus.
Yes, it's plus or minus 5.
Okay. Now, notice something about that problem. There was something else. A couple things. First of all, what is that called? What does DOPES stand for?
DOPES stood for, it was determine both sides.
No, difference.
Oh, difference of perfect squares.
That's it. Okay. That's a difference of perfect squares. When we see it, we want to recognize it. How would that factor if I decided, well, I'm going to solve this problem by factoring?
So that it'd be x plus
No,
3.
the first one's always minus.
Oh yeah, minus 3, and then the next one's going to be x plus 3.
Okay, notice I still can't solve this now because it's not equal to 0. It's equal to 16. Only if it's equal to 0 can I then solve it, because if it's equal to 0, I can say, well, that's equal to 0 or that's equal to 0. But if it's equal to a number, I haven't progressed the problem at all. I don't know how to solve this. So that's the wrong path to take. Now, notice that I could, instead of add 9 to both sides, I could subtract 16 from both sides. And now I have this. Now it's equal to 0. Now DOPES will help me a lot. Factor that.
Let's see, x minus 5, and then x plus 5, and then the answer is just going to be x equals 5.
Hold on. You have to set both of them. That has to be 0, and that has to be 0. So what do you get when you set the first one equal to 0? You get x minus 5 equals 0. Solve that.
Just add 5.
And then you get x plus 5 equal to 0. Solve that.
And then you just put x minus 5. Or not x minus 5, just minus 5.
So notice that when I did it this way, I still get plus or minus 5. And in fact, I can't make a mistake doing it this way. Doing it the original way, where we added 9 to both sides, I could easily make the mistake of coming up with x equals 5 as my solution. Well, that's not the solution. The solution is x equals 5 or x equals minus 5. When you lose a solution, you have made a mistake in the problem. Okay? How would I solve this?
Alright, so
It's quadratic, first of all. Recognize that. It's very useful recognizing when you're looking at quadratics, because almost always when you're looking at quadratics, you want to make one side 0.
So, what we have to do is isn't it the perfect squares thing where we had in
Not quite, no. This is just another technique of factoring. Make the right side 0, first of all. How do I do that?
subtract w?
Okay. Notice that if I divide by w, I don't make the right side 0. I make it 1. But if I subtract w from both sides, then now I have this. Important to realize that you can't combine those. You can't subtract w from w squared. This is an apple. This is an orange. But now what can I do? This becomes a factoring problem. In other words, when I make one side of the equation 0 like this, I'm planning on solving it by factoring. And meaning that I want to end up with something times something else equals 0. Then I will be able to solve it. So how do I get something? Right now we got something minus something. I can't solve that. How do I turn that into something times something? What's the first technique of factoring? The first thing you should always look for to see if it works. Greatest common factor. Okay. Is there a greatest common factor here? No. 6 does not divide into 1. Even.
Oh, yeah, I forgot that definition is like the letter there that has a 1.
Consider the variables. Is there a greatest common factor variable? W. In other words, W divides into that evenly, and W divides into that evenly. So, when I'm factoring, that's what I'm doing, is I'm dividing each term by what I determine to be my greatest common factor. Well, there's my greatest common factor, W. What's left? What's this equal to?
That is equal to 6 minus...
No. When you are dividing, you subtract the exponents.
6W.
Yep. And what's W divided by W?
-1.
Okay. Now I can say that that whole thing's equal to 0. And now notice what I have. I have one thing multiplied by another thing equals 0. Well, that allows me to come up with all of my solutions. What are my solutions? Remember the way to do this. Once you get the product of a bunch of stuff, it doesn't have to be 2 things. It could be 3 things times one another. If you have 18 things times one another equaling 0, one of those 18 things has to be 0. So the way we're going to solve this is we're going to set each part of what's being multiplied equal to 0. So that can be equal to 0, or that can be equal to 0. Solve that. In other words, there's one solution. This is going to give us a second one, but we got to be able to solve that equation. You can't do anything in algebra unless you can solve equations like this.
Add a 1 to both sides.
Okay, so give me the second line.
Alright, so it's going to be 6W equals 1.
Yeah, now notice this is not a quadratic. That's a linear equation. I'm not going to try to put 0 on one side. I don't need to. So clearly that is the correct first step, to add 1 to both sides, because my goal is to end up with W. What's the next step?
Divide 6 by both sides.
Divide both sides by 6. Okay. So the left side, those now cancel. So now I got my W, and the right side is 1/6. So my 2 solutions to this problem are 0 and 1/6. And if you go back and look at the original equation, you see that 0 clearly is a solution. If W is 0, 6 times 0 equals 0, that's true. But the other solution of 1/6 works also. In other words, 1/6 squared equals 1/6. Well, what's 1/6 squared? It's 1/36. So this becomes 1/36 on the left side. Is that equal to 1/6? Yes, it is. I'm going to divide top and bottom by 6. 1/6 equals 1/6. All right. we'll just do more of this until, in other words, factoring covers a lot of stuff. Greatest common factor, it's difference of perfect squares, it's factoring a quadratic that has a constant, it's factoring radicals, it's doing square roots of both sides of the equation. All 5 of those are part of factoring. And we could probably spend the rest of the summer on just this alone. But we want to make sure that by the time you go back to school, you can do all 5 of these proficiently. Okay? If you can, you will be in great shape. I'm not saying that I'm showing you everything you're going to need in algebra, but it's a lot. It'll get you through those sections of algebra with A's. If you can just become proficient at the stuff we're talking about. Okay?
August 11th is when school starts, so you might have to. Hi, Mr. Powell.
Yeah, hi, Mrs. Mondragon.
Hi, how are you today?
Good.
Good. He was going to ask you if he could move Friday to Thursday at 11. Is that open for you?
Yeah, I'm sorry. You're wanting to increase his session?
No, his Friday session, we wanted to move to Thursday.
Oh, yeah. I can do that. I'll do it right now, and it's done.
And then, because he's going camping next week, so he's not going to be around.
Okay.
And he's going for a job interview this afternoon, and we don't know if he's going to get it or what his work schedule is going to be like. So, would it be best after he gets back in camping, he starts school? And we wanted to continue with at least 1 session a week to refresh, ask questions, and all of that. Would it be more beneficial for him to go in and schedule that each week as he finds his open time?
He can do it either way. Either way works. The only thing he can't do on his own is set up a regular time on a regular day every single week. I can do that on my end. So I have him scheduled like Tuesdays and Fridays for the summer, but so he can do it that way if he finds a time that he wants and he wants to lock it in so that nobody else can grab it. He's certainly able to do that. But if he doesn't know his schedule and it's flexible and he needs to, then you can just go to my website and schedule whenever you can find a half-hour slot. It shouldn't be that hard in September. I don't really start getting booked heavily until October.
Okay. Well, he's starting on the 11th, and I want him to at least meet up with you a minimum of once a week.
Okay.
You know, he can have his questions from his class. He can say,
that'll be very helpful. Although what we've done so far this summer is 100% stuff he's going to need to know.
Oh, I know that.
There's nothing that we're covering that he won't need to know. So at this point, I'm not worried about what to cover. But it will be a little bit more helpful once he gets his back in class to cover what they're covering on that given week. Will be better for sure.
I think for the month of August, he's going to have to be on flex time.
Okay.
And then in September, everything will calm down enough, school-wise, sports-wise, job-wise, driver's training-wise, that he can have a set time.
Okay.
That sounds good. Is that okay with you?
Sure. That's absolutely fine.
So from this point, I think do we have 4 more classes or 5 more classes? I think it's 5 that are.
Okay. So let me just make sure. So he's not going to have his Tuesday, August 4th session.
Correct. He will not be here.
Right. And then I got him down for Friday, August 7th.
And he won't be here for that.
He won't be here for that. Okay, let me cancel that also. And then the next week, August 11th, Tuesday, should I cancel that one?
Yeah, but he'll be in class then.
Okay, let me go ahead and cancel him for the rest, and then everything else will, you'll schedule it individually.
He will schedule it individually.
Yeah.
Perfect.
Okay?
Thank you so much. You've been a wonderful help so far this year.
Well, thank you.
I can't wait to see the difference it makes. So
I think it'll make a big difference. I do. I think I see a lot of progress taking part on his part.
All right. Thank you.
All right, Chris. Bye-bye. Goodbye.